Hi, everyone, and welcome to the Data Architectural Virtual Group meeting for October the 10th. Today we've got Robert Cain talking to us about Pester the Tester, PowerShell bugs beware. Very happy to have Robert here today. He doesn't know this, but because of his PowerShell or his Pluralsight courses, that's everything I know about PowerShell. Some upcoming meetings for the virtual group. A second meeting this month on the 24th, we've got Mark Vanderweil and Serene from HVR Software to talk about processing data in the cloud for on-premises analytics. And then we're going to skip November, and we've got Tim Mitchell coming back on December the 5th to talk about temporal tables. So you can register at the data architecture website there down at the bottom, dataarch.pass.org, to register for those and anything we schedule coming up in 2019. Talk about our sponsors. Our first is Nutanix. They've been with us for a couple of years now. We're very happy to have them. So go ahead and check them out at that bit.ly link down at the bottom there, and thank them for sponsoring the group. And our second sponsor is HVR Software. They've been very good to us. And again, if you come back later this month, you'll talk to Mark, and his presentations are always very exciting. PASS Summit coming up in just a few weeks. I know Rob and I are both going. If you use that discount code there down at the bottom of this slide, you can save $150 on your registration if you haven't registered yet. Look forward to seeing everybody there. Some upcoming virtual group webinars. We are one of several virtual groups. You can find a virtual group on just about any topic and in any language. You can go to the PASS website and see what you have of those coming up. Here's some more. And that is all I've got. So with that, I'll switch it over to Robert.
Okie dokie. And I'll show my screen.
Here we go.
All right, so hopefully you can see my About Me page on my blog. And I'm referencing this because it's got all my various information. I am, as he indicated, a course author for Pluralsight. And I've got a whole bunch of courses. If you just scroll down to my About Me page, you'll see the 16 courses I've done so far, including one called Testing PowerShell with Pester. So there's a 4-hour course right there. If you don't have a Pluralsight subscription, just shoot me an email, info@arcanetc.com. Link to my email is on this page. And I can send you a coupon code good for like 30 free days so that you can check out my courses. The other big reason to come here, though, is when we do these webinars and whatnot, people always ask, well, when can I get the code? That's always the first question that get asked is, where can I get the demos? Well, if you look down here, you'll see Robert's GitHub site. Well, if you open that link up, it takes you over to my GitHub site, which is just github.com/arcanecode. And if you go into my repositories, just go to the PowerShell one, and scroll down, and there are several Pester ones, but the one for this particular course is Pester Basics. If you click on it, you'll see all of the different source code that I'm going to be showing you. I also have a nice little zip file called pesterbasics.zip that you can use to just download all of this in one big gulp. All right, let's go actually start looking at code. Now, hopefully the folks who are on the call are familiar with what Pester is at the very least. Pester is a tool for testing your PowerShell code. The cool thing about it is written in PowerShell itself. So all of the code is available. As a matter of fact, if you come up here to github.com/pester, you can have access to the entire source code repository. You can have access to their wiki, which has all of the information on it about all the different commands that you can use, the formatting of those commands, and so forth. So lots of good information on this site. Okay, so enough of that. Let's go actually look at some code. So the first question is, how do I get Pester? Well, you probably already have it on your system if you installed Windows 10. The thing is, the version that came with Windows 10 is like version 3 dot something. I think it's 3.6. Well, that's nice, but it is not the most current version. We're up to version 4.4 now. So you want to make sure you get the most current version. If you are on PowerShell 5, you can use the PowerShell 5 package management system to install it easily. If you're on an older version of PowerShell, I'm sorry. I'm so sorry. But, go ahead and upgrade it. No reason not to. This also works on PowerShell 6, by the way, or PowerShell Core, whichever one you want to call it. Now, to actually do this, you simply come down here, and I've got a few commands that kind of give examples of the new package management system. But what you want to do is use find package Pester, and this is going to look in the repository. And so when I run this, it'll come up here in a second. You can see that in the PowerShell gallery, the current version of Pester is 4.4.2. So I'm going to switch back to my codes window, and let's go see what I have installed on my system. So we're going to use get module, we're going to give it the Pester name, and we'll use list available to show me what I have installed on my system. So you can see I had 3.4, which came pre-installed, 4.3.1, and then I went to 4.4.0, and I see I need to upgrade in the near future to 4.4.2, but not going to do that right now. We don't want to threaten the demo gods with any issues here. By the way, if you notice me jumping back and forth, there are also shortcuts in the PowerShell ISE for moving around. I currently have my code window full screen because I'm broadcasting on a 1280 by 720. You can actually use this to toggle back and forth, or you can use Control R to switch back and forth, and you can alter your view with these buttons up here. So here on this toolbar, you can see I split the window, but if I do that on this screen resolution, we're not going to see very much. That's why I'm using this split window. So we'll come back over here. And then the other way is I can use the F8 key to execute a command. So if I use F8, it's going to run this. So I'm going to be doing a lot of hotkeys. I'm a keyboard kind of guy. So if you don't see me clicking on stuff, that's what I'm doing. I just like to let folks know. All right, so let's actually say we want to install Pester. The first time I want to install it, I'm going to use install-module Pester. -4 says go ahead and install it, even if I've got another version on here. Now, this other little skip publisher check switch is kind of unique for this situation. What happened was when the 3.4 version that you saw a second ago that came pre-released with Windows 10, it uses something called code signing to validate that, yes, this publisher, it created a code signing certificate that said, hey, this is Microsoft pushing this out. Well, the problem is when they went to no longer being shipped with Windows, but instead coming through the PowerShell gallery, they used a different code signing certificate. So what happens with install module, it says, oh, wait a minute, you've got a version on your system already that was signed with a different certificate. And so it's going to want to stop things. So that's why you need to use skip publisher check, because it says, I know what I'm doing, go ahead and install the new version. All right, so once you've installed it, from there on out, you can just do update module to keep your Pester module up to date. And that's what I'll be doing after this webinar, is upgrading mine to 4.4.2. Okay, so that's how we get Pester on our system. And as I said, if you're on a version of Pester if you're on a version of PowerShell prior to version 5, the Pester site on GitHub has complete instructions for how to install it on those older versions of PowerShell. All right, let's start by looking at some very basic Pester tests. I'm in the file basicpester.tests.ps1. One of the things about Pester is it wants the files to be named with a .tests.ps1 extension on them. Now, it's not absolutely necessary. You can actually call those tests, but you have to do some manual intervention. We'll talk more about that when we actually talk about how to invoke a Pester test. So what does a test look like? Well, if we see what we're seeing on the screen now is a basic Pester test. It starts with the keyword describe. Now, there's a lot of subtleties to this, because describe is actually a PowerShell function. Remember, Pester is completely written in PowerShell, so the describe is actually a function within the Pester module. The other thing, you may look at this and go, now wait a minute, I thought functions were supposed to have the verb dash noun syntax. Well, normally they would. However, the folks who designed Pester decided to implement it as what we call a domain-specific language. We want the language elements for this to be readable and applicable to the testing world. So instead of the traditional verb dash noun, they actually went with function names that are almost readable as sentences. So the first function that we're going to need to create a basic Pester test is the describe function. And all describe does is it says, okay, here is a block of tests. We name it using the first parameter to the describe function, and it's just some sort of a text string. It could be, single quotes, double quotes, whatever, but it is some kind of a text block that we pass in. And then we have our squiggly brace. Now, again, this is something that you may not think about at first, but all of this is what PowerShell calls a script block. A script block is passable into a function as an entity. Now, with this, and if you're familiar with like a for each loop, for each is built into PowerShell, and with it, you can actually start the squiggly brace on the next line, and PowerShell doesn't care, it works fine. But because this is actually a function, it thinks the function call ends at the end of the line. So if I were to actually execute this, it would generate an error because there is no second parameter, which is the script block. So you always have to have that opening squiggly brace on the same line as the describe block. You could use a line continuation character if you wanted to, but there's not a whole lot of benefit to that. So we have our describe block. The next thing we want to do is actually create a test. So our test is here on the next line with the it statement. So similar to the describe, our it function has a parameter, a test that should be true. It's a string that holds the name of the test. And then at the end of it, we have another script block. There's our squiggly brace for it. And in here are one or more conditions that all have to come out to true in order for this particular test to pass. So here I have one condition, and I'm making it very easy. I'm just saying $true. This could be a calculated value, some kind of text, lots of different things that we'll see here in this presentation. But the output of that is piped, and you can see there is my pipe character right there. It is piped into another function within Pester called should. And should takes the inputs and evaluates them and then returns a true or a false to say that this particular condition of the test passed or it didn't. So with the should, there is a switch that says what kind of operation we want to do, and the B is the simplest of these. So should dash B, and so what should this be? Well, this should be true. And of course, this one's always going to pass because true is always going to come out to true. But let's take this and let's actually see what does this look like when we execute it as a test. And just how do we execute a test? Well, I have a little script here called invoke-basic Pester tests. So what I'm going to do is I'm going to set my directory to C:PowerShell Pester demo. I'm going to clear the screen, and then I'm going to invoke Pester. Invoke-Pester is the command to go out and run Pester tests. After the name of the commandlet, I'm going to give it the name of the test that I want to run. So in this case, I'm going to run that basic Pester tests.ps1. So let's execute this. And here you can see the output. At the very top of the screen, you're going to see it says executing all tests in And there is the name of the script. And then the next thing it says is I'm actually executing this script. And then we see our describing basic Pester tests. So that corresponds to our describing. Then you can see the plus indicates that a test should be true, actually executed successfully and passed. We see that it took 38 milliseconds. We see that all tests completed in 38 milliseconds. And then we have our summary at the bottom where we have 1 test passed, 0 failed, 0 skipped, 0 pending, and 0 were inconclusive. All right, pretty cool, pretty straightforward. So let's start expanding this a little bit and let's see what other kind of tests we can do. So let's come back to our basic Pester tests. And I'm going to come here and we'll just cut him. I'm going to drop below, paste him in real quick. And so now we have a second block called describe basic Pester tests. And in it, we actually have 2 tests. We have a test that should be true. And this is similar to the one you saw a moment ago, but in this particular one, we're going to use a little variation. Instead of having to say -b $true, Pester also has a built-in -b true to save you from having to pass the $true in. And this actually does make it a little more readable. So we have true should be true. And we also have a condition that could fail. And what I'm doing down here is I wanted to show you what a test looks like that fails. So I have $false being piped into should be true. And I just realized I have a typo here. There we go, fix that. So with this, you're going to see 1 test passes and 1 test fails. And I want you to see what this looks like when we actually execute it. So we're going to come back over here. We'll run this again. And so now you can see there is my second describing Pester tests describe block. The first one passes. And the second one, a test that should fail, does indeed fail. We see we expected $true, but got $false. Then it has the line of code of the test that actually failed our test, and it gives us extra information about that we're in the script block, what file we're in, what line we're in. And then down at the bottom, we see our summary. So we had 2 tests pass, 1 failed. Nice little summary that lets us know what we're doing. All right. So let's come back and let's get a little more advanced here. So we're going to come over here. In addition to just checking for values, we can also check to see if certain things exist. So here I have a block called it should exist. And then I have a file name, PowerShell. You can see here, invoke basic Pester tests. I'm piping this file name into should, and this time, instead of a B switch, I'm using exist. And so what this is going to do is it's going to look on the file system in the directory I've indicated and see if the file exists. And so we can actually easily come back over here and run this now. And we can see describing should exist test, should exist, comes out 51 milliseconds. We can see green shows us it passed. So yay, our file exists. All right, let's come back up. Let's see some more. We'll further expand this. And we're going to expand our test now to use variables. So here we have should exist with variables test. And I've put the name of my file into a variable. And then in the it, what I'm passing into my string is I'm using the string interpolation function. So I'm using double quotes and I'm putting my sum file variable name as part of the name of my it. So if I come back over here and execute this, you're going to see that PowerShell Pester invoke Pester tests should exist. Now this is actually pretty cool because with this, you can actually use PowerShell as part of the generation of your tests. So you could write, for example, a loop that looped over a list of files and created a test for each individual file within the loop. So this is just one example, but remember, all of this is in PowerShell, so you can really leverage the PowerShell to do some very creative things within your Pester tests. So when you're looking at these, you probably could think, well, okay, this looks pretty cool, but I might have a lot of tests to test my particular module or function. So organizing those might be a little problematic. It's if I just have it after it after it could get a little hard to read. And fortunately, the folks who wrote Pester agree with that. So they created something called the context. So let me just scroll down here and get rid of this bottom one, and you can see some of these different context blocks we have. So the context is kind of like a mini describe. So within the describe, I place the keyword context. I give the context a name. And then in the script block that I then pass in as the second parameter to context, I have a group of it statements. And you can see here I have numerous ones, and these are just kind of takeoffs on the ones you already saw, where I'm just doing trues and falses. I also just put all of this onto the same line. It's certainly possible. You don't have to wrap it around multiple lines. But then at the bottom, I have a closing script block brace that says, okay, here's all of these tests. So before I run this, let's actually go down and look at some of these other context blocks because they show you some of the other ways you can use should. In this case, what we want to look for is negative assertions within our second context block. So I've added the keyword not. Actually, it's a switch to the should function not. And so we simply say should not be true, or here's another variation, should not be, and I passed in $false. So you can certainly use negative assertions by using the -not switch. Now, so far we've used simple Boolean, but here I can actually do calculations. So in this first it test, I'm creating a calculation, $x equals 42 times 1, and then I'm taking that value of x, putting it into should, and I'm looking for an exact match on the value of 42. Now, in addition to looking for exact matches, we also have greater than or equal to. So here on the next line, I have y equals 3 times 11, so it should be greater or equal to 33. And here again is another one where I'm actually just taking a calculated value and passing the output of that calculation into the should statement. And here I'm saying should be greater than 30. All right, let's look at some string tests now. There's various ways we can test strings. The first of those is the be like. So what be like does is allow for wildcards. So here I have my test value string of arcane code, and you can see it should -be like, and I have arcane asterisk. In a be like scenario, it is not case sensitive. So it doesn't matter what case my search string and the matching string are, as long as the actual letters match up, we're in good shape and it'll return a positive. Now, if you do need case sensitive matching, there is a second version called should be like exactly. And that basically says, hey, this has got to be matching on case, a case sensitive match. All right, so the next thing we're going to look at is how can we do testing with arrays? So I have my array, and I've listed 3 items. I've got my arcane code, and then I've got a link to my Redgate articles, and I'll show you these at the very end. I've got several articles on PowerShell and testing with Pester on Redgate Simple Talk site. So I've got a simple arcane.code.red that'll jump you there, and then of course link to my main blog, arcanecode.me. So we're going to say my array should, and then if we want to look inside of an array, we need to use the contain switch. So what we said is, does the array contain the value arcane code? And sure enough, it will. And then the other part for working with arrays is the have count. So we can actually make sure our array has the correct number of items in it by using have count, which is what we did in the last line. So let's go actually look at the output of this. We're going to go back here to our invoke Pester tests, and we're going to execute it. Let me scroll up a little bit. So there's some of the other tests we've already done. Here we go, describing grouping using context. And so here is our first context block, and you can see here that it organizes these subheadings. So when you have things broken up into context, it makes it very easy to scroll through your test results and determine what's where. So very easily readable. I have should be true, should be false. There's my negative assertions. Here is my calculations. $X should be 42, should be greater than or equal to 33, should be a calculated value. Here we can see testing to see if arcane code has arcane. And there is my item array tests. Now, grand total for all of these tests, we had 17 pass and the one failure. And the one failure we saw already. It was up here with the one that we deliberately designed to fail. So within this basic Pester tests, I actually had multiple describe blocks. So there's a describe block, there's another describe block. So your tests don't have to be limited to a single describe block. You can have many describe blocks existing within the same test. Okay, so now that you've got a little bit of the basics under your belt, we've learned that you use describe to outline a series of tests. You have the it statements that are the individual tests themselves, and you have context, which is a convenient way of organizing within a describe block the tests that you want. And then for a test, you've seen that we use should to evaluate the results, and we have different switches we pass in, such as be true, be false, be greater than, exist, contains, and so forth. When it comes to testing, there's actually 3 different kinds of testing that you want to do. The first type of testing is called unit testing. In unit testing, you want to test in what they call isolation. You want to make sure that what you're testing only is the code for the developer. So let's come over here and see an example of this. Here is a function called pretend to do something. And what it's going to do is it's got a command block, excuse me, a param block in which we're going to pass in a file name. So we just have a write verbose statement. So we're just going to use write verboses to kind of emulate that it's actually doing things. So the first thing, though, is we're going to check to see if our output file already exists. We're going to use test path to see if it's there. And if it is, we're going to write out a warning. And then we're going to return false, which is going to exit our function. So basically, if the file is there, we want this to exit early. Now, you see that it's calling test path. Well, we just said when we do our tests, we want to do our tests in isolation. Well, think about test path. There's a lot of things that could go wrong with test path. First, there could be a bug in test path that nobody's discovered yet. Second, the file that we're trying to check for may be on a drive or directory, say out on the network, and all of a sudden that network resource goes away. Or it could be a number of other conditions. Well, we don't want to have to go down the rabbit hole of our tests failing and us trying to figure out, well, why did the test fail? Was it something in our code? Was it something in test path? Was the network suddenly taken away? That's just something we don't want to have to focus on. We just want to focus on our code. So what we want to do is replace the command test path with our own code that we know the result of and that we know works. And that methodology is called mocking. We're going to create a mocked version of test path. And we'll show you how to do that in just a second. I just want to run through the rest of this function real quick. We're going to scroll down, and then you see all I've got is a couple of write verbose that we're going to pretend to read from a database. We're going to pretend to do some calculations, and then we're going to come down and we're going to write some text out to a file. So I just have a text string, and then I'm piping that into out-file, and it's going to write it out to disk. And then finally we return true that says our operation was successful. We've created a new file. All right, so let's come back over here to our tests. We're going to come here and we'll start by clearing our screen. And then we're going to set our directory to C:PowerShell Pester demo. We're going to go to that location, and then I'm going to execute the file that has the script. Now, it's important that we have this in here because each time through, we want to make sure we load the freshest copy. So you always want to make sure to execute the script that you're about to test. That way you have the most recent code in memory, because if you think about it, you run a test, something fails, you're going to come back and you're going to fix it, and then you're going to run the test again. Well, this takes care of you've forgotten to rerun it, or you've got the old version memory. This just takes care of all that for you. So always make sure to include this. All right, so let's scroll down a little bit. And here I have my describe block, unit tests, and I've added a new switch here called tag. You can add a tag to any describe block, and then later we can use this to control which tests get executed. So I'm giving it a tag of unit. Now, this could be named anything I wanted to. I could name this John or Adam or whatever. So the name isn't important. However, standardize on something within your organization. Here, I've standardized on the word unit to indicate this is a unit test. You could actually use the word unit test as one word if you wanted to, however you wanted to put it. I then have my opening squiggly brace. I'm then going to create a file name that doesn't exist. So a file that doesn't exist, blah, 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 fooey.txt. And so within here, we're actually going to have two tests because we need to test for all possible conditions. So the first test we're going to do is we're going to make sure the function returns a false if the file already exists. Well, how can we do that without actually generating a file? Because part of unit testing is we don't actually want to leave artifacts out there on the disk. Well, that's where our mock comes in. So here is our keyword mock. That is a PowerShell function within the Pester module. And then I'm going to use the name that I want to mock, test path. I'm then going to have the code that I want to mock up. So here it's very simple, so I just put it all on one line, and it's return true. So even though my file name doesn't exist anywhere, I want the function to think it exists and exit so I can test that section of code. So now that I have the mock in place, I'm going to come down here. I'm going to pretend to do something. I'm going to pass in a file that doesn't exist. That's my parameter. And note at the end, I've put the -verbose switch. It can often be useful when you're conducting tests manually, if you're actually executing the test yourself, to include the -verbose switch. Now, if you're including this as part of an automated testing suite, that may not be necessary, but it's definitely useful, I have found, for doing it when you're running them interactively like I'm doing here. So I pretend to do something, I return it into a value, And then I say it returns false if the file already exists, and this should indeed be false. So there's our first test. We want to make sure that it properly exits if the file already exists. Now, in the second one, we want to make sure the function returns true if the file doesn't exist. So in this next example, we're going to mock our test path again. And when we do it a second time, it's actually just going to replace our first mock. And this time we're going to return false because we know our file name does not exist. Now, the other thing we want to do is actually not let a file name get written out. So here we're going to also mock our out-file. And because we don't want out file to do anything, we're just going to create an empty script block, just some squiggly braces that says don't do anything. So once again, we're going to call it using verbose. And this time it should go through our function and it should assume the file doesn't exist. And in the real world, of course, it would actually be reading from the database and doing all this stuff. But here it's just doing all those right verboses. And at the end of it, if all of our code was successful, it should return true when it exits the function. So let's actually go run this. And we can, as I mentioned, use this tag, as a mechanism to actually go run this. So let's come up here, and I've got another file called invoke mocks tests. And so you can see here, if I invoke the first one, it's going to run all the tests, but we only want to run the unit ones. So when I invoke Pester, mocks pretend to do something tests.ps1, I can pass in a tag so that it only executes those particular tests. So I'm going to run this, and you're going to see it's only run my unit tests. So we're going to return false so the file already exists, and sure enough, it did that. And then in our next test, we return true if the file didn't exist and processed OK. So both of our tests passed. Yay! They worked. Okay. So let's look now at the next kind of testing. The next kind of testing after unit tests are called, let's see, the brand reveal. Yes, they're integration tests. Now, integration tests are interesting in that when you do an integration test, you typically want to call the real version of the function. So here we're actually going to call the true, we're going to call the true test path. We're also going to call out file for real. So we don't want to mock with an integration tests. However, with an integration test, you typically don't want to leave a lot of artifacts left behind. So how do we solve that? Now, because our test is designed to actually write data out, it's got to write a file out, but we don't want to leave those files laying around. So we could create a directory somewhere, and we could then go look at that directory and then go delete it afterwards. But that's an awful lot of cleanup to have to do. So fortunately, the folks at Pester thought, you know what? This is going to be something that happens so common. We want to be sure that we actually carry this out. So let's actually take care of this for the end user so that they don't have to worry about creating all of this. And that's where the test drive comes in at. There is a special variable called $test drive. When you hit in your code the describe block, part of the execution of the Pester describe function, it sets up a special spot on your hard drive to temporarily save things into. And that then becomes exposed through the $test drive variable. So what I've done is I set up a first variable that is the name of my file, mytestdata.txt. And then I've seen a second variable here called mytestdata, which is the combination of the path in my test drive with the mytestdata file. I then come down here and I say test using a file name that won't exist. So I'm going to pass this file name. Now, I know this file name doesn't exist because Pester set up this folder for me brand new when my test began. So I know that's going to be empty and there's nothing there. So I know the first thing I need to check for is the creation of the file. So pretend to do something. So at the end of this, the only thing I should have returned to me is true, and that would indicate the file actually was created. Now, after I do that test, I want to run the test again, but first I want to validate that the file name was actually created. So I'm going to come down here with another it, and I'm going to say should exist. My file name should exist. And that's how we can check to see if that file is there. So now I want to make sure my function behaves correctly if the file name already exists. Well, we know the file, if the previous test passed, this test right here, this one passes, then we know that file exists. So now we can run our code, and as part of pretend to do something, it should run the test path, it should find the file, and then it should exit gracefully by returning a value of false. So that's what this last part of this test does. So let's come back over here and we're going to run this again. This time we're going to run this for our integration tests. And so sure enough, everything worked fine. We returned true if the file didn't exist and processed okay. And then we see if the output file, my text, exists. And then we say, this is the actual call to the function, returns false if my test data.text existed. So all three of our tests here passed. Yay! All right. So one more. The final one is my acceptance test. Now, acceptance tests are often lumped in with user acceptance testing. With acceptance tests, it's perfectly acceptable to leave things laying around on disk. You could use test path. There's no reason, excuse me, test drive. There's no reason not to. But a lot of times your end user says, well, I want to run the script, then I want to actually go open up that file and I want to make sure I can check the contents to see what's there. So that's where the acceptance tests come in. Let's come back over here and see what those tests look like. So here we go with the acceptance. And this time I'm having to go get a directory name. This is where I'm going to output to. My test file name is going to be acceptance test data.text, and I combine them together into a test file path. We'll scroll down and we're going to say, well, let's make sure the file name was not left over from our previous test. So we need to make sure we go get rid of it. Well, we're going to test to see if it's there. And if so, we're going to use remove item. We're going to use -force because I don't want it to ask me silly questions like, are you sure? By the same token, if the file didn't exist, I want to use error action silently continue in case there were any errors deleting it. So next up, we're going to use this with a file name that shouldn't exist. So pretend to do something. We're passing in that test file path, and it should come back and tell us, yep, the result should be true. Now we're going to test for the existence of our output file. Hey, did we manage to create that file okay? If we did, great. And now we're going to say we're going to add a test to see if the file existed. So here, pretend to do something, passing in our file name now that it exists should return false. So these tests wind up pretty similar to the integration tests. And a lot of times you can copy the integration tests into the acceptance tests. The difference being a lot with acceptance tests, you tend to want to leave the results of your tests laying around afterwards, such as records in a database, files on the system, and so forth. So let's go execute that particular test. We'll click here, we'll run this, and you can see here is our output file, and everything passed correctly. All right, you can actually call multiple tags at the same time. Here you can see I've got my tag for unit and my tag for integration both listed. And if I run those, you can see there is my unit test results up at the top. Sorry, unit test results up here at the top. Then there's my integration tests. I can call everything, let's scroll back over here to the left, by just calling the name of the file. And when I do this, it's actually going to execute every test it finds, unit, integration, and acceptance. Okay, pretty good stuff. I do want to mention that I can also invoke tests by simply going into that particular folder and saying invoke Pester. So let me come back over here to my output, and we're going to clear the screen. And now I want to show you test.ps1. I actually have two files in here, basic Pester tests and mocks pretend to do something. Okay, both of these have the .tests.ps1 extension. If I just do an invoke Pester and I hit enter, this is going to go out, and you can see this is running all of the tests that I have in this particular folder. So the most common way of executing an entire set of tests is to simply navigate to the folder where your .tests files are stored at, and then from there just running invoke-pester, and it will go out and run all of the tests. Now I could have also chosen to use the -tag, the -pester -tag unit, and it's going to run all the unit tests it finds. So, or anything without a tag. So there we go. That shows me a couple of different ways I can actually run and invoke Pester. So I'm not seeing any questions out here. So hopefully people are hearing me, and I haven't been sitting here talking to myself for the last 47 minutes. Are there any questions out there? Not seeing any.
I don't have any.
Okay, well, good, good. Hopefully that means everybody's understanding things. Since we've got a few minutes left, I want to show you a couple of things real quick. First off, we jump back over here. In addition to my Pluralsight course, over on Redgate's Simple Talk site, I have several articles. And that's where some of the code you're seeing today has come from. So if you go and look at my Introduction to Testing Your PowerShell Code with Pester, or my Advanced Testing of Your PowerShell Code with Pester, you're going to see some very detailed instructions on how to do everything that you've seen here. Looks like my internet's running a little slow. Okay, here we go. So you can see I scroll down and we have the pretend to do something and the mock. So if you want a little more detail on what we covered today, you can scroll through here and you can read these and gain quite a bit more information on what we've done today. The other thing I want to mention is that I have a new article that's going to be coming out. I'm hoping this week, it may be next. It's actually with the editor now that's going to come out on here that's going to talk about how to test modules using Pester. And there's a few things you need to know. So too, why don't we just pull up that real quick since we got a few minutes. Now, oh, by the way, a lot of people ask me this. This little side thing over here, this is something called the PSISE Explorer. It's a free tool that's available through GitHub, or you can also install it through the PowerShell gallery, just like we did with Pester. And it puts basically a file explorer window over here. And so it makes it very, very easy to do demos because I can easily jump back and forth across different files. So let me just close all of this real quick, get these out of the way. And I'm just going to show you just a little bit to kind of whet your appetite. Let's come in here. Now, for this article, oh, somebody asked a question. Can I explain the Skype parameter? Is that what I'm reading that?
To be skip.
Oh, the skip parameter. Essentially what skip does is it will skip a test. So this allows you to include tests that, maybe you're still developing that test, but you need to run the whole test suite. So you can say, skip that test. Uh, or maybe you have an older test that you don't feel like you're ready to delete yet because you may need to roll some code back or something like that, but really the test isn't valid at this point. So you could put a skip in there so that that test won't be done. So that's what skip does. There's also a similar pending one. Am I going to share this session? Yes, absolutely. Carrie can speak to where the session will wind up being as a recording, but as I mentioned at the very, very beginning, if you go to my GitHub site, github.com/arcanecode, I have a PowerShell repository, and in the PowerShell repository, there's one called Pester Basics where you're going to find all of this code. Or you can just use arcanecode.me, and arcanecode.me takes you to everything I've got. Okay, cool. So that's great for anybody who came in late. Thanks for reminding me to show that. All right, so let me come over here. Now, what I have here is a module. Well, the fictitious scenario I set up for my article said, we are a company called Podcast Site, and what Podcast Site does is it aggregates different podcasts from across the universe, and we create individual PowerShell modules for each podcast that we want to download, and we want it to generate some XML, some HTML, and so forth. So for that, I'm going to be using a podcast called No Agenda because the one nice thing about the No Agenda show is they've got a royalty-free license. I can use their stuff for anything I want to, no restrictions. The other thing is they have unique episode art for each podcast, so each one gets a new little album art cover, which makes some of the demos pretty cool. So you can see here for my module, make that a little bit bigger, you can see I've got a whole bunch of different functions, and what one of the dictates of the requirements was each function has to go into its own file. And so one of the things as part of this I want to do is I want to create a set of tests for the structure of my module. So here I've got one called Podcast No Agenda Module Tests. And in it, you can see for this one, I've let the unit and acceptance tests run for the same describe block. And you can actually include multiple tags here. So if you want a particular describe block to function for multiple purposes, you can certainly do that. The other thing I discovered is with testing for modules, and what we're really doing is saying, does the module have the correct setup? Does it have a PSM1 file? Does it have a manifest file, a PSD1? And does that have the correct information in it? Is the code valid? Are my functions out there? So these are the kind of things that you can do. And I see a question about SMO. I'll get to that in just a minute, Todd. Those are the structural things are what we're testing for with this particular example. And I have found that this winds up becoming the same for a lot of modules. So I put my module name here as a variable. The other thing you want to do is you want to make sure you change your folder to wherever you're executing these tests from. And we can do that by using the my invocation that says, hey, I'm executing this file, where am I? And you can reference the mycommand.path value to get the path to that location. So within here, I have a context block, and first thing I do is I use should exist, and you can see I am highly leveraging the power of my string interpolation. So I'm using the variable here, and I'm looking for the module name.psup1 to exist. I'm looking for a manifest file. And another switch that you can use is file content match. What file content match does is it looks in the file and says, hey, does this actually exist? In other words, does this text appear in the file? And this is an important one because I find a lot of people wind up just copying manifest files from an old module to a new one, and then they forget to update them with the correct information. So this is a good way to catch that kind of thing. Do our functions exist? And then this is an interesting one. We can actually test to see if our module is valid PowerShell code. So what we do is we load the code for this particular module into memory for the PSM1, and then we're going to call something in the system management automation set of libraries. Everybody has heard PowerShell is based on .NET. Well, it is, and the particular .NET libraries PowerShell comes from is system management automation. One of the classes in that library is called PS Parser. And PS Parser allows us to call static functions. These are functions that we can call without actually having to create an object out of this. So what I can do is call the tokenized function of my PS Parser class. I can pass in my file, and then I have to pass in an array that's going to hold any errors that it found. Now, that variable does have to exist. That's why I have on this line $errors equals null. I just have to get that variable into PowerShell's memory. It doesn't actually have to hold anything. And we actually need to pass it in down here by using the bracket ref. If you're familiar with some programming, what this does is it passes the address of this variable rather than the contents of the variable into my tokenized function. So with that, after it calls the PS parser, it says, well, did I have any errors? This is going to be an array. If the count should be 0, and if it is, I pass. Now, if it's not, I could have actually gone to the effort of displaying the contents of the $errors variable so that provides additional feedback. That might be a good application that you could add to this. This is just kind of where I went with this so far. Now, I talked about how we could use context and loops to actually generate some really unique stuff. So here, I've got an array of all of the functions that are supposed to be in this module. You know, I've got good requirements, and I'm able to leverage those requirements in order to write my tests. And that's one thing about testing, and I'm going to get on my soapbox for just a second. Good requirements are essential to the success of any project. So if you really want your testing to succeed, you have to know what you're supposed to be testing for. And that's where the requirements come in. You get your good, clear requirements. Based on those requirements, you can write tests. And then from those tests, you can actually start writing code. And yes, I said it in that order because that's called test-driven development. You can write all of your tests first, and then you start writing your code. And once all of your code passes all of the tests, you're done. You know your code's complete, and you can go to your boss to say, I'm finished. Here's the tests that prove I'm finished. You know, they validate that my function does what it's supposed to do according to the requirements. So that's one reason that requirements are so vital to your success. So absolutely insist on good requirements. If you have to, write them yourself, but get somebody to sign off on them. Okay, make sure that everybody understands this is the work I'm going to be doing. I can't stress this enough. Okay, so real quick, okay, I don't know. Sorry, somebody was griping about the time set. Sorry, Paul. Sorry you missed it, but it's going to be recorded. So let's come down here, and you can see I've set up a for each loop. And each time through the loop, it's going to create a new context block for each function. And then for that function, it's got all these different tests. And this is what I kind of wanted to show you, that how you could be creative with this was because with string interpolation, you can actually create something that has some very cool testing to it. You know, you can actually get some really nice output. You can see I'm just testing using things like the file content match to make sure my code is actually correct. Here's another test to make sure my code is accurate. And then finally, we're going to make sure that each one has a tests function. So that's what this one does, and I'll leave it to you to actually run this and see the results because we are out of time. I want to answer the question about being a SQL DBA. Can I speak to Pester's ability to test SMO objects? You know, that's going to be the same as working with SMO and PowerShell because Pester is just PowerShell code. So what you would have to do is just write your code. For example, all these SMO are indeed objects, so you would have to use object-based notation as part of your it tests. You know, maybe table dot columns equals, you know, must be equal to, should be greater than 5 or whatever, that kind of thing. But there's no special things you get with Pester for testing SMO. Probably not the answer you were hoping for, but that's what it is. All right, I want to mention one last thing. Carrie mentioned at the very beginning talking about going to PASS. I will be speaking at PASS, and I hope you come to see me. It's going to be that first Wednesday afternoon, and my session is going to be called The Joy of DevOps. So if you're interested in the DevOps movement or you're fairly new to it, I would encourage you to come. It's going to be a concepts talk. We're going to be talking about things about kind of the basics around DevOps. We're not going to get into technology. We're not going to talk Puppet or Chef or any of those other things, but you're going to learn the foundations you need to go forward with a DevOps implementation within your organization, and hopefully some things on how to help sell it to your boss to get things out the door faster. And, you know, let's face it, a lot of us dread doing those releases. So DevOps is a way that you can make your life better. So with that, I'll turn it back over to Carrie. I don't see any more questions. So let's, any questions to wrap this up? Or Carrie, anything you want to say?
I don't have any more questions. Robert, thank you very much. This was very informative.
Sure.
Yeah, for those of you that need it, I'm going to get the recording posted to YouTube sometime this evening, hopefully. And I will send out an email to the group with links to Robert's GitHub and a copy of the recording and everything for you to watch later. I think that's all
And
I've got for now.
Yeah, the module, by the way, the module code is in Pester-module. I got a lot of the PowerShell code here, and the article that really explains how to do module-based testing should be out on the Redgate site, I'm hoping within a week. So just check back there. Thanks for coming.
Excellent. Thanks, everybody. Thank you, Robert. Have a great rest of your day, everybody.
Bye, everyone. Thanks for coming.